everyone. Today we are going to present our storage and backup solution for newspaper digital archive. I am Arrshia Kareema and this is my teammate Yasmin Banu.
Hello everyone. So, newspaper digital archive. What is this? It's a collection of old newspaper issues stored in digital formats. It contains articles, editorials and advertisement from past years. Some of the benefits are listed here. It is useful for research, fast checking, preserving cultural heritage, primary source for films and documentaries. The problem we addressed is that a publisher needs long-term archival storage for newspaper and photographs. We are working with key data like scanned archives, metadata, public access logs. Our tasks include information lifecycle management, setting archival policies and choosing between NAS or SAN, along with planning for backup and disaster recovery. Information lifecycle management. This slide shows the phase of information lifecycle management. During creation, scanned pages and metadata are captured through optical character recognition and manual tagging. In the use and access phase, frequently accessed content is stored on fast storage like SAN. For retention, less used files go to NAS or cloud cold storage. In the archival phase, we use warm support for data integrity. Files are only removed during disposition based on specific policies. Archival policies. Our archival policies include a retention period of 100 plus years and the use of non-proprietary formats like TIFF and PDF-A. We keep all versions of edits, perform regular integrity checks using SHA 256 and apply role-based access control to manage who can access what. Here we can compare NAS and SAN. NAS is used for storing scanned images, metadata and logs. SAN is used for optical character recognition processing and metadata databases. NAS use protocols like NFS and SMB, while SAN used for fiber channel. Both are highly scalable, but NAS is low cost and easier to manage, while SAN is costlier and more complex.
So now we are going to see about what each type of storage we are going to use. First off, we have SAN, which is storage area network for active workloads. Because SAN has high performance and low latency and high input and output per second, we are using this for OCR files, optical recognition files. The text recognized alone is saved in SAN without the actual photographs from the files, and tagging data, which is the metadata created during the editing of the files by the publisher. And in database storage, structured metadata, which is the metadata which tells us about the titles, dates, categories, etc. and user requests in order to be convenient for the users, and the requests should reach the server on time. So we use SAN. Next we have NAS. In NAS we store scanned archive, which is high resolution newspaper images, and OCR output files, public access logs, which include the login and logout time of the users and how much what the files they have accessed. All the user data will be stored in NAS. The reason is NAS allows file level access. It has large capacity and it is ideal for storing large volume of files which are static, and it has lower cost than SAN, so much lower cost. So we use NAS. And support tiering. Tiering means after a certain period of time, it moves the unused data or least frequently accessed data to another form of storage. So it is very useful. After it moves, after some period, the NAS moves those files to tape libraries and cold cloud storage like Glacier, Azure, etc. When data is not accessed, it is moved to tape or cloud by the NAS. So example, the old newspapers from the 1950s or some faulty documents, etc., they are moved to the tape or cloud. NAS can automatically migrate this. There is no need for the intervention of the user, and etc. This is also very cost effective, very cost friendly. It is much cheaper than both NAS and SAN, and this saves cost without deleting anything. You can save all data. Next, backup and disaster recovery. So our backup strategy include full plus incremental backup. We do incremental backup daily, and on Sundays alone the full backup is conducted. So the backup media are tape and cloud. Frequency is metadata, database, etc., because the users access the archive on a daily basis, and all their data needs to be updated continuously. And scanned files we upload weekly. Disaster recovery plan. The recovery point objective is 24 hours, and recovery time objective is 48 hours, which is the maximum amount of time that is allowed to recover the data after it is lost or due to some problem. Offline backup, geo-redundant cloud storage or second data center. Suppose any natural disaster like earthquake occurs, this offsite backup will be very helpful. Snapshot replication, which is a snapshot of the data at a particular period of time. We just take a snapshot of the whole archive. And location and number of copies. The 3-2-1 rule, which is 3 copies of data, 2 types of media, 1 copy stored offline on the primary site, and the location include primary site, secondary site, and cloud storage. So now we have a general block diagram of how the data is transferred. So first the data comes from users, researchers. They publish the records, and it comes to a web application, to our application server, and then while users use it, metadata is created, and then the OCR processing engine takes the text from the pictures, and it is stored in tier 1 storage and tier 2 storage, NAS, and after some period, if it is not accessed, it is moved to the long time archival, and after that it is moved to, either if it is not needed, it is deleted, otherwise it is moved for backup.